Hey everyone, let's see this question 24. In it, we have given five random variables u, v, w, x, and y, and its joint distribution is given. So it is given that probability of u, comma v, comma w, comma x, comma y is equal to p of u, p of v, p of w given u and v, p of x given w, and p of y given w. Okay, and now we have to say that which of the following statement is false. So you have to read it carefully because it is asking which of one of these is false, not true. Okay, so it means there will be three which are correct and one will be false. So let's see. So let's factorize it and let's see who's dependent on whom and how. So as you can see, u and v are not dependent on anyone. Okay, so u and v are independent. Okay, so let me write these here. U and v are independent. Fine. Then W depends on U and V. Okay. So the second thing we know that W depends on U and V. Next thing we know that X depends on W and Y depends on W. Okay. So X depends only on W, only on W, and same way y also depends only on w. Now we can see each option and see if it is correct or not. So y is conditionally independent of v given w. So although w is dependent on v, but once w is given, which is written here, that given w, so once w is given, y is conditionally independent of v. That is correct, because once w is here, we don't have anything to do with v. Okay, once w is w we have, then v is not needed. So yes, y is conditionally independent of v given w. That is correct. Same way, because x y depends only on w, same way x depends only on w. So same way x is conditionally independent of u given w. So that is also correct, because we once we have given w, x will become conditionally independent of u. Then we have u and v are conditionally independent given w. Now we have written here that u and v are independent. We have not talked about what if we have given w. Okay, we'll come to that because this option will need a little more explanation. So first let's talk about d, that y and x are conditionally independent given w. So again, because both variables y and x has nothing to do with each other, so once w is known, both are independent, right? So this option is also correct. I mean this statement is correct, not the option, because we wanted to tell which statement is false. So these three statements are false. Now let's see why this statement is false. Okay, we knew that these three statements are true, and we need to know that which of why this u and v are conditionally independent given w. This is incorrect. We know that probability pu and pv, so u and v are independent, but once we have given w, so this kind of structure is called a v structure. Let me change the color. It is called a v structure or a collider. Okay, so what happens when there is a common effect, right? U and V are independent, but when they both cause a common effect, that is W. So U is also causing this W and V is also causing this W. So given this W, it makes U and V dependent. If W were not there, then U and V are independent. But if we have this common effect that is caused both by U and V, then they are conditionally dependent. Okay, so let's understand this by an example. Okay, So let's say there is a job hiring scenario. Okay. So let's say you can be that candidate's education. Okay, there is some candidate who is going to be hired, and U is candidate's education, B is his work experience, his or her work experience. Okay, now these two things are completely, sorry, not this V, this V. These two things are completely independent. A candidate could have different educations and different work experience. Some may be very high educated but has less work experience, or some may have higher work experience but less education. Some may have both, some may have none. So these two things are independent. They don't have much to do with each other. But let's say there is a common factor which is caused by both of these. Let's say there is this W, which is that candidate is hired. Your candidate get hired. Now this hiring is caused by both of these, right? Hiring is again a effect of your education and your work experience. Okay. Now given this W, now these two things become dependent. How? Now let's say I know that one candidate got hired, and if I knew that this candidate has not very good education, then I can predict that this candidate must have very good work experience. Or if candidate doesn't have much of a work experience, then I can know that this candidate may have studied from a very good institute or may have a very high education. That's why he got hired. So this is an example when there is a V structure and some cause, some effect has happened by both of these, then given that these two become dependent. So U and V are independent when W is not given. Once W is there, U and V become conditionally dependent. That's why this option is, this statement is incorrect, which makes this option correct. So which one of the following statement is false? That is C, that U and V are conditionally independent given W. Thank you.